And hello to everyone. Welcome to this career fair. It's an amazing event. I'm very, very pleased with the level of interest that is out there in the global space market, the Canadian space market, and of course at MDA. There's a lot of growth ahead of us, which I will speak to a bit today. And it's not a blip, it's real growth. It's a change in the market. There's a huge future coming in space that I'd like to speak to a little bit. And talk to you about the opportunity that I see as a corporation to be able to join MDA and work at MDA in the space sector. Before I do that, I'm going to play a video. We have a new video that just kind of shows a little bit about MDA and MDA as a place to work and why we feel people should come and consider working at MDA. So I'm going to play around with this platform just for a minute, get into share mode and share a video that hopefully I don't screw up too bad and I make it work okay. So just give me a sec. Here we go. I'll play this video. Give this a listen for a couple of minutes, please.
When you were young, you dreamed about it. As you grew older, you started to put the pieces together and began making the things of your dreams a reality. We know you because we are you.
We dream of a future
where people and countries communicate
and act on global matters together.
We dream of extending humanity to the moon and other worlds,
and ensuring its safety back home.
and as we put the pieces together,
We have stretched out our arms
and lent a helping hand.
gave humanity the eyes and ears to predict events and changes
that might threaten us or our planet. We gave the world a platform
to communicate and collaborate as one.
As one.
as one.
Through passion and innovation,
We have pushed ourselves further
And further.
learning,
iterating and progressing.
And we are just getting started.
how far can we go?
How far can you go?
Because without people like you,
it would still be just a dream.
Hopefully that worked out okay. I will switch now and go into PowerPoint mode and use a few charts to make some comments about what's going on in the space sector and what's going on at MDA. Hopefully you can see those charts that I'm sharing right now, and we'll go from there. So a new day at MDA. We feel like it is a new day at MDA as we move out into the future. Right now, we feel, and we talk a lot about the fact that the opportunity in space is large and expanding rapidly. We use this diagram to be able to sort of summarize that a little bit. In the bottom left-hand corner, we talk about the space to Earth economy that's emerging in orbit, that is emerging in orbit around the Earth. We see every day right now an increase in the number of low Earth orbit constellations for communications to bring broadband communications, the Internet of Things, and soon 5G mobile communications for mobility to everyone around the Earth. In Earth observation, we increasingly see satellites being launched to observe the Earth using different sensors, from optical cameras to radars, like MDA is a world leader in, to hyperspectral, to different forms of methane, environmental emission sensors, and the list goes on. So there's a strong economy that's growing there. Right now, the communications economy in orbit around the Earth is about $175 billion a year. The Earth observation market or economy around the Earth is about $18 billion a year. So these are very strong and growing markets as we move forward. The overall market on this diagram is about $380 billion a year of economic activity right now, which has been forecast to transition to about $1.5 trillion a year by the time we get into the 2030s. So we like to feel, and certainly we do experience every day, that the space economy is real, that it's here to stay, and that it's growing rapidly as we go through the next 10 or 20 years. Away from that space to Earth economy is a growing space to space economy. An economy that's growing further out in orbit. A lot of that's led by the current thrust and activity as we return to the moon. The United States through NASA is leading the Artemis program, of which we keep seeing in the media more and more countries signing up to the Artemis program to participate in the return of humanity to the lunar surface as we go through the second half of the 2020s. And we see other projects in addition to Artemis going on. China and Russia have signed an agreement to establish a lunar base on the moon. A number of commercial activities are applying for different types of missions to be able to go to the lunar surface. This time when we go to the moon in the second half of the 2020s, the goal is not to visit like we did, back in the 60s. It's now to go and stay, to be able to have habitats, to be able to grow food, do mining, figure out how to live, have communication networks on the moon. MDA is expected to be part of a lot of that activity as we go forward into the future. To support activities on the moon, we talk about a new space station depicted here called Lunar Gateway, a new space station that will orbit the moon. And of course, when we talk about Canadarm3 a lot as we go through the day today, that's for Lunar Gateway in that part of the program. All the lessons that we learned through the 2020s on the moon will then be, continue to be exploited through the 2030s as we keep going up to the top right of this diagram and humanity starts to visit Mars, and we start to inhabit Mars and create, habitats there as the next phase of the journey of space exploration and advancement of humanity to be living on multiple planets. With the volume of satellite activity in the bottom left corner in that space to Earth economy, we'll transition from around 3,000 active satellites today to over 30,000 active satellites as we go through, the next 5 to 10 years, which is creating up a whole new market for on-orbit servicing to be able to inspect satellites and change their orbits or deorbit them if they're in their life, and in some cases refuel them to extend their life. There's a whole economy that's growing here for robotics-enabled vehicles to be able to go and interact with satellites and modify their missions over time. Those same spacecraft will be able to be used for on-orbit assembly and manufacturing, so that we can start to create new and different types of structures in space, so that what we do build in space is not limited by the size of the nose cone of a rocket, and we can create new and different structures moving forward. There's a growing market that's coming for space tourism. We start to have tourist visits in orbit, tourist visits even to the International Space Station, in addition to introducing new purely commercial space stations increasingly moving forward. All of these activities require sensors. Some require robotics. All require communications, the things that MDA builds moving forward. As we go forward further into the future, in the bottom right, we start talking about space-based mining. 17,000 asteroids reachable from Earth that can, change the nature of where we get, minerals and resources in the future. In this context, then, we have MDA. MDA is a proven leader across the space economy. We're an advanced technology provider to almost every aspect that I just described, except for launch. We have experience in over 300 missions, satellite missions that we've put technology on, successfully introduced to orbit. We're now in our 4th generation of radar-based satellites that we are now developing in our next generation of synthetic aperture radar satellite capability to introduce into orbit. We've introduced robotics on the space shuttle, flew over 100 missions there. And then Canadarm2, next generation of robotics with Dexter on the International Space Station, where we've now provided support over the last 20 years to the robotic operations on the International Space Station, with MDA having over 3 million hours of engineering and technical support to the planning and conduct of on-orbit robotic operations. Absolutely unique in the world. In the communication space with low Earth orbit constellations, MDA has been involved in 3 LEO constellations to date, and with Telesat Lightspeed announcements recently, moving into our 4th low Earth orbit constellation. And we've had technology on rovers on Mars now for over 13 years, with our next generation of technology on rovers on Mars heading up in 2022. So a really broad range of proven experience. Our personnel get to work on hard problems. They get to develop engineering solutions to this wide range of space problems. and get to see the results of their work going into orbit, constantly pushing mission first, constantly achieving mission success for our customers. As I mentioned, we provide advanced technologies across the space ecosystem. We participate in almost everything but launch. We're organized as a company into technology areas that we've grouped into business areas, 3 business areas that are depicted here, each a world leader in what it does. First, we have robotics and space operations, where we develop sensors and robotics, on-orbit servicing solutions, provide operational support, and then technologies for exploration and rovers. The second is satellite systems, whereby we're world leaders in the provision of especially communications technology for satellites, but also Earth observation. We provided satellites, subsystems for antennas, electronics, and payloads to all satellite manufacturers around the world for many, many years, over 300 missions, like I mentioned before, and increasingly seeing ourselves participate in low Earth orbit constellations. The third business area is Geo Intelligence, where we design, develop, deliver, and operate full Earth observation missions. We develop and deliver ground stations to customers around the world to be able to process Earth observation data, and are increasingly involved in multi-sensor geospatial analytics to be able to fuse and compute the information products that people need from Earth observation data and deliver those Earth observation products to people all around the world. I'll spend a few minutes on each of these business areas just to be able to characterize them a bit further. In satellite systems, the world is moving out increasingly with a strong need for high-speed communications. The United Nations has declared that access to the internet is a basic human right. Canada has committed that every Canadian should have access to high-speed internet by 2030. All of these types of commitments are driving increased need for broadband internet, for the use of the Internet of Things, for mobile communications, 5G supported moving forward. In rural and remote communities around the world, the most logical solution to bring this high-speed communication is going to be from space. So we're going to increasingly see space-based networks providing this communication need around the world, and the integration of space-based networks with terrestrial networks to be able to bring the solutions that people need. At MDA, as I mentioned, we deliver the necessary technology to support these advancements. We have a wide range of experience in geosynchronous orbit satellites, delivering payloads, antennas, electronics to the full range in the market. Last year, in the 2020, in the global market for geosynchronous satellites, there was 21 awards last year around the world. MDA has content on 17 of those 21 awards. LEO constellations, like I mentioned, now putting up hundreds and thousands of satellites in constellations. MDA is increasingly participating as a technology provider in LEO constellations, most recently through the Telesat Lightspeed announcement, where we're providing the digital antennas for their first 300 satellites, and are in discussions to do full satellite manufacturing of those digital satellites at production rates of up to 1 satellite per day in our facilities in Montreal. We're also putting communication systems on a range of spacecraft, and have recently been contracted for studies to start to design the networks for the lunar surface, to be able to bring the communication networks to the moon. Next business area to talk about is Geo Intelligence. Earth observation data is used to be able to, for a range of really strong purposes around the Earth. In the climate change business, there's about 50 variables that people have identified that we need to monitor for climate change. 26 of those can only be monitored from space. Space plays a key role in providing persistent observation of the Earth for the full range of activities that are listed down the left-hand side of this slide. MDA is really busy lately in illegal fishing detection. We've announced a large programs partnering with Canada's Department of Fisheries and Ocean to be able to provide illegal fishing monitoring for island nations around the world, and pilot studies of us fusing the data from 4 to 5 different sensors into an information dashboard so that countries can monitor all the fishing activity off their coast and detect and identify the illegal fishing activities and be able to cause interdiction for those. We're really strong in this area because of the technologies we deliver. We own and operate RadarSat-2, which is the most sophisticated broad area surveillance synthetic aperture radar satellite in orbit today. We have a network of ground stations that we've been delivered around the world, over 75 ground stations to customers in over 25 countries, pulling down data from not just our satellite, but up to 20 different satellites or missions from different operators around the world to be able to create the intelligence picture that people want to from Earth observation data. As I mentioned, we're increasingly involved in analytics, artificial intelligence, and machine learning-based analytics to be able to fuse and analyze the information from Earth observation satellites to deliver information products through end-user platforms to customers around the world, increasingly on a subscription basis. And lastly, robotics and space operations, which you'll hear a fair amount more about as we go through the day, where there's, as I mentioned in my opening remarks, a growing market for the entire community of space exploration, space tourism, on-orbit servicing, assembly, and manufacturing, and increasingly in the future, getting into things like space mining. We have the technologies needed for these activities. We have a range of sensors. We got awards last year to put lunar landing sensors on, I think, 5 different vehicles, with another 5 expected this year. So that's just exciting to be part of, like all this return to the moon, having our sensors on those vehicles. We have a range of other sensors for on-orbit activity, proximity operations, docking and berthing, robotic operations, and the like. A full range of robotics is in play within the MDA business, that's increasingly becoming commercial. We're increasingly spinning off and commercializing our robotics activity so we can sell them to other companies that are interested in participating in this aspect of the new space economy. The investments in venture capital in space has doubled in size each of the last 3 years. As a result, there's an increasing number of companies looking to put together space solutions to participate in this market, and we increasingly have the opportunity to provide technology for those solutions. Some of those solutions include on-orbit servicing and assembly, in addition to rovers for the moon and for Mars. I mentioned our operational support experience. We're investing at MDA in a next generation of mission control centers in our facilities in Toronto and Brampton. And we will be increasingly providing operational support to on-orbit robotics and operations as we move forward with our business in this area. As a result of all this and the contracts that we're receiving, we're experiencing significant growth. We're transitioning from $400 million of revenue that we had last year in 2020 to around $850 million of revenue in 2022 to an estimated $1.5 billion of revenue in 2025 based on our current business forecasts. Last year, we hired 350 people, even through COVID, onboarding almost all those people virtually and welcoming them to our company. This year, as we move out and get ready for 2022 growth, we've already hired at twice that pace, picking up 350 new people in the first 6 months of 2021. We will continue to be hiring at that pace as we move forward. As we do that, we're putting a lot of effort into making sure that we have an outstanding work environment. It is our goal to be recognized as a top 100 employer in Canada, and I'm convinced that we will do so. So that's a quick summary, a quick tour of the neighborhood of the world at MDA at the moment. I thank you for listening to me for 15 or 20 minutes there to be able to get the view of how we see the growing space economy, the position of MDA, and the opportunity for us and for you moving forward. I'm hoping that you have really fruitful discussions with the recruiters and the management that we have available today, and that you get all the answers to the questions that you need, or if not, we'll chase each other down and get those answers. And we look forward to be able to have really solid discussions and welcoming the next group of new recruits into the community of MDA.
Welcome, everyone, and good afternoon. So I was asked to speak today about MDA engineers and the impact they make. And that really got me thinking about my career over the last 20 years and what it meant to have an impactful career. And so that really makes up 2 major components. One, the impact engineers at MDA can have on society, but it's really the careers that they build, the day-to-day aspects of their lives here at MDA that is very impactful. And that's the 2 types of things that I want to talk about today, is both the impact to society, but really the impact to the engineers themselves. So what does it mean to be an engineer at MDA? What is the role that they have? What is their day-to-day tasks like? There's many aspects. A lot of people think it's writing reports and looking at drawings, but there's so much more to that. And that's really a little bit of what I want to get into today. So let's talk about the obvious, that the challenge of being an MDA engineer is that space is hard. There's so many things to consider, whether it be the extreme environment, the radiation, exposure to potential space junk and meteorite damage, as well as just operating in the vacuum of space, that makes the challenge of engineering so difficult. It's one thing to put a robot together. It's one thing to put a robot together that needs to operate in those harsh environments. It has to be lightweight. It has to be strong. It has to be able to be operable by astronauts. There's an interface between man and machine that the engineers at MDA really have to tackle on a day-to-day basis. And they obviously have and come together to create the most iconic Canadarm, the most iconic robot that we have for Canadian engineers, which is the Canadarm. It operates in all of those tough environmental conditions and has been the backbone of the shuttle program throughout the 80s and 90s. It handled payloads, it operated astronauts on spacewalks. It was truly an astronomical feat at the time. It didn't take just mechanical engineers creating gears and joints and manipulators. It was really a massive team that worked together on software, electrical engineering, mission operations, navigation and guidance, as well as systems engineering to create such a large robotic arm that was usable in space. They are always pushing the boundaries here. So you may think, okay, now that they've done one robotic arm, and that was almost 40 years ago, is that it? Is we're done? And the truth of the matter is, we're always creating custom solutions. As many of the engineers around me have said, I've never solved the same problem twice. And you may think that one robotic arm in space is just like any other robotic arm in space. But the truth is, the mission is changing. Every time that we demonstrate the performance of the Canadarm in space, we take on new challenges and new requirements. You may remember the Columbia disaster, which occurred when tile damage interrupted the integrity of the heat shield upon reentry. And the Canadarm was again called on to extend its mission literally by working together to develop an extendable boom so that we could see the entirety of the shuttle, inspect the integrity of the heat shields, and then work with astronauts to develop tile repair techniques. Just to give you a scale of that size of the problem, that Canadarm with the extendable boom used to actually survey the shuttle is over 10 stories tall. And that's not the only extended challenge. Once we tackled Canadarm, Canadarm 2 came along, which has been an integral member of the International Space Station. It was used to assemble the Russian capsule. It's that picture to the top left is actually the SpaceX Dragon module being shown docking. And we've developed autonomous, the handyman of space, which is the Dexter robot on the bottom right, which is able to take care of the maintenance requirements of the International Space Station. So the challenge here is ever growing, ever expanding, ever changing as we grow our mission requirements. And is that it? Of course not. We're going to the moon. And so we are really looking at extending our operational efforts. Again, it will require dealing with lunar dust. It will require dealing with autonomous operations where lunar night may impact communication. So the challenge is ever evolving at MDA, and that is what engineers at MDA get to experience, that excitement of not doing the same old, but really changing and evolving the designs and tackling new problems. But is that the only thing that we do? No, we're actually beyond robotics and space. We've contributed to actually answering the questions that everybody has about the universe. Where did we come from? How did we get here? And what is the first signs of life? MDA has actually got multiple aspects of on the Mars planet right now. We have 3 major programs we're contributing to on Mars rovers. That top left picture is a picture of Phoenix, which landed in 2008, and MDA contributed the meteorological station on that Phoenix, which detected the first presence of snow on Mars. And the Curiosity rover, the bottom left photo, actually contains a X-ray spectrometer that we worked with partnering universities across Canada and the US to develop an ability for scientists to determine the chemical makeup of rocks and soil on Mars. The top right and bottom right photos is actually an incredible mission that is made the news recently, which is the Osiris-Rex mission. MDA contributed to a laser altimeter on the Osiris-Rex mission, which went and traveled out to the Bennu asteroid. It's about a 6-year mission. It left in 2016 and will return in 2023. But it made news really big last October as the Osiris-Rex actually touched down and gathered a soil sample of the Bennu asteroid. It could be the true answer to where did life start? Where did water come from on this planet? And is there potential for life traveling on asteroids through our solar system? And those are the types of challenges and questions that MDA engineers get to participate in answering. So all of this allows MDA engineers to come to work and be creative. Be creative in tackling the problems. Be creative in really finding interesting solutions. The way we test things, the way we think about the problems, we can really bring our full creative muscle to the table. And it's not just the way we tackle the problem and solve it, but the tools that we develop along the way to get there. This picture, top left, top right, is actually our Dreamer Lab, which is a zero-gravity robotics lab with mixed reality, which allows us to model what it's like to do a free flyer capture in space, where you can actually see what we see on the left and what somebody wearing a HoloLens mask sees on the right. You can actually see a full-scale version of the International Space Station and stand beside it and say, how are we going to dock this SpaceX module? So as I said before, MDA engineers don't just sit in front of drawings and write reports. They have hands-on learning. How else do you learn about space but actually travel in zero gravity? The picture on the left is actually an engineer testing medical devices that are designed to operate in zero gravity. He actually got to go on the notorious Vomit Comet, which is the zero-G simulator airplane that does sinusoidal dives and climbs to simulate zero gravity. And he tested his hardware in 25-second samples in order to demonstrate that this scientific tool was working. We also have engineers creating how astronauts may have to actually repair some of the tiles on the shuttle program, and during creating simulations of what that would look like. It's very hands-on. You get to see the real world. We've had engineers do multiple stints at our at the Houston operations base for NASA and participate in mission planning and mission operations, as well as get to go to Johnson Space Center and Kennedy Space Center to actually see the shuttle and Canadarm ready to go. But we didn't stop at space. The robotics lessons that MDA has learned, the knowledge that our engineers have come together with, has really expanded beyond space into the medical field. NASA approached us with the University of Calgary about robotic operations in an MRI machine. So this is new technology for MDA at the time, not knowing, well, obviously there are magnets, so you have to deal with that on a robot. But what does it do to the imaging? What does it do to the pictures that we're capturing when it's operating inside an MRI? And so our engineers worked with doctors, with patients, witnessing surgeries, actually working in the MRI machines to develop a robot that could perform surgery inside an MRI. And that was the development of the neuroarm. And we expanded on those skills again, using it to develop a breast biopsy robot, as well as, while working with the doctors, develop new robots that can actually track the movement of the doctor during surgery and assist with locating the camera. It keeps the doctor and the surgeon from having to stop and reposition cameras and optical equipment. It can actually track the movement of the surgeon live in surgery. And we didn't stop there. I mean, once you capture space and once you capture the medical field, what else is left for harsh environments? Nuclear field. So we've actually worked to create nuclear nuclear robots that can inspect the reactor to ensure that everything is safe on maintenance downtimes. We don't have to send personnel in, the safety of the workers is maintained, and you have a robot do those dangerous missions. So I've talked a little bit about what engineers get to do day to day, what exciting work they get to do, but that doesn't stop with what they experience in their lives, that the contribution that the MDA engineers get to have. We extend that on to society. Through the Canadarm program, Canada got to participate on the international stage as members of the International Space Station. And really that Canadarm was our ticket to ride and create the astronaut program for Canada, creating famous astronauts like Roberta Bondar, Mark Garneau, and my son's personal hero, Chris Hadfield. I wish it was me. It is not. It's Chris Hadfield. And there are personal stories. This is a picture of Paige Nickerson, who is the first patient to have been operated on by that neuroarm that removed tumors from her brain. She is a young mother, and she now is operating without the pain of those tumors causing debilitating pain. And so we have a personal impact of that, not just the neuroarm, but the breast biopsy MRI robot has allowed us to impact women's lives in remote locations where they don't necessarily have radiologists on site to be able to do the breast biopsy there live. We can do it remotely through the IGAR robot. And Canadians feel our pride. An Ipsos Reid poll in 2008 actually identified the Canadarm as one of the greatest Canadian achievements of all time. Rumor has it that I think beer was at number 90, but besides that, the Canadarm really tops the list. We are the source of pride for all of Canada on the world stage. And our employees see that. They carry it. They know what they've contributed, as you can see on our $5 bill every day. Also, our engineers want to give back. They want to engage with the universities and future generations. They are participating in partnerships with schools to develop those scientific instruments on those Mars rover. The Curiosity rover was actually a partnership with 6 other universities. And that's really expanding their knowledge and their skill set and really readying the next generation of engineers to come, as well as inspiring future generations of children. And we actually encourage our employees to participate in university outreach, like teaching certain courses. So I actually will have one final thought before I end this. And that is, that this presentation is not compiled by myself. The pictures, the quotes you read, the stories about what these important robotic advancements contribute actually came from all of my coworkers. I said I was coming to a career fair today to talk about how great engineering is at MDA, and just the flood of feedback about people wanting to say what they contribute and how they feel about their work. Their passion is just bursting through. So there's a camaraderie that exists when so many creative, intelligent people come together to solve the world's hardest challenges in a very R&D environment. And that's the impact that MDA engineers can have, is that inspiration for everyone. Thank you.
Excellent. Thanks so much, Nancy.
Great to join all of you. I think I'll just start by giving you the answer to the quiz at the end, why it's so important to me to spend a little bit of time sharing with you my perspective today. And it really comes down to what Mike Greenlee was saying earlier in his presentation, and I fully agree with him. I believe that we are on the cusp of something truly important for the world, but specifically for Canada. And I'm just really thrilled that we have this many great minds online today looking into this, getting their questions answered, giving it some serious thought, because I do think the space market is going to triple in the next 10 to 20 years. I think that is a very reasonable estimate. I think Canada has a great starting position. This isn't something we're just getting into. We have, as we'll talk about today, we have decades of experience, and we have a record of bringing excellence to the field. And we often sell ourselves short. And I think it's really important that we get serious and intentional about securing Canada's opportunities in that growing market, because it's important for solving problems within our country and around the globe. And it's important for our economic future, jobs of the future. I really believe these things. I was really impressed by the numbers that Mike mentioned in his presentation, how many people MDA has hired over the last 18 months and how it's grown just in the last 6 months, and it'll grow going into the future. I think that bodes really well for Canada. But as has been brought up a couple of times today and in the video, we're just getting started. We really are as a country. The opportunity, I think it's hard for people, even decision makers, and even in government, to really wrap our minds around what is possible, what is reasonable for us to do. But I think the main point is we need to be bold. We need to be willing to take risks, and we need to intentionally be hungry and go after this for Canada's future. And of course, that future rests in young Canadian minds. And so I'm thrilled to speak with you today. I want to share some images while I chat with you today. So let me just go over to that, get that running. So hopefully you're seeing some slides now. I liked how Nancy put some perspective on space, how hard space is. I think I take it for granted. I think most people take it for granted. And here's just like an example of something that's been happening in the last couple of weeks. You've seen a picture of the International Space Station before and the huge solar arrays, but they're getting older and their performance is degrading slowly as expected. And we have more demand on space station. As we do more science, we need more power, more electricity. And so recently, engineers have solved this problem by creating new solar arrays to be installed on top of the existing solar arrays. And that's what you see in this image here. Hopefully you can see my mouse when I circle it. But these are the new solar arrays, and this is two of them, and they will unfold. You can imagine them kind of butterflying open and then unfurl and cover up this gap essentially in between the two big panels and just provide us with new power. But of course, international collaboration is what makes the International Space Station happen. And I just want you to understand how involved Canada is in this project. Of course, from the robotics perspective, how did those solar arrays get there? Well, they flew up in a SpaceX vehicle in the trunk, and then Canadarm is required to remove those from the trunk of the SpaceX, position them like here on the POA, which is Canadian Space Robotics. That's what's holding onto this solar canister. This is where Canadarm deposited them. before the astronauts could come out and do some of the work to prep them for installation. And then my colleague, Jenny Seide-Gibbons, fellow astronaut, she was in mission control for all of these spacewalks, or 3 spacewalks to get this job done recently. And she was the ground IV, which is the person who basically spends a ton of time beforehand with the spacewalk team, developing the procedures that the astronauts are going to execute, testing them out in our neutral buoyancy laboratory. That's the big pool where we go down and practice spacewalks. We have a 1-to-1 scale mock-up of the space station, and figuring out how we're actually going to do this in space. So she did all that work with the team, and then on the day of the actual spacewalk, she's the one in mission control, the voice between the ground and the 2 astronauts doing the spacewalks, which was Shane and Thomas, and guiding them through all that steps, the interface between the ground team and the astronauts doing the job. So just one example of how Canada participates on the International Space Station. Now, I want to go back in history and just talk about why I think Canada is so well positioned for the opportunities that lie ahead. And it really goes back all the way to 1962. Canada became the 3rd country to have a satellite in space. And I have to tell you, I have to admit, I was a little slow as an astronaut to pick up on the importance of these historical milestones. I used to hear about this all the time, 3rd country in space. And I was sort of like, yeah, that's great, but let's talk about what we're doing now. But now when I kind of look back on it, I realize how important it is. It really comes down to vision and understanding how hard it was to have that vision, to take those risks, to make those leaps, especially as a small country like Canada. And we need to remind ourselves repeatedly that we need to be that bold all the time. We can't rely on the successes of the past to assume we're going to succeed in the future. We have to be hungry, we have to be bold. So in 1962, we launched this satellite because of an international partnership with the United States. We brought something of real value, a satellite that was going to bring important scientific data about the atmosphere around our planet. And because of the value it brought, the United States agreed to help us and launch it. And we shared that data. And that was the beginning of something very, very important, our international collaboration with the United States, which has opened us up to international space collaboration. And it's important to recognize we wouldn't have the space program we have in Canada today if it wasn't for our allies to the south, if it wasn't for NASA in the United States. I mean, obviously, they have the launchers. They are a much bigger program. And it is really our partnership with them that has allowed us to thrive. But we have thrived throughout that, and we will continue to do it. So an important step in our history in 1962. And we never really looked back from there. We went on to develop many more satellite systems, to learn enough about the ionosphere, to bounce signals off of it, to develop communication satellites. So that legacy led to being invited, by bringing real value and showing that we were invited by the United States to participate in the space shuttle program. And Nancy did a good job of telling us about Canadarm1, the boom you see on the end of Canadarm, how it was instrumental in returning Columbia to flight after we lost that vehicle, or returning to flight after we lost the Columbia vehicle and its crew. But there's a lot of really challenging engineering there. And I mean, I just want you to stop for a second and think about it. When Canada took on that challenge, there had never been space robotics. I mean, this was big, this was bold. There was a lot of opportunity to fail here. There's a lot of opportunity to be embarrassed as a country. And so just a reminder, again, we need to be bold. And that legacy is now trickled down. And as Nancy also pointed out, led us to the International Space Station and Canadarm2. Canadarm2 just wasn't a new version of Canadarm1. It was an entire leap in engineering and capability. With Canadarm1, it was always astronauts controlling it directly from the space shuttle, not having to communicate over vast distances. And when we first started using Canadarm2, it was sort of like that as well. But we have learned to evolve, and now almost all the operations of Canadarm2 are done from the ground. And this is important because it took a long time for us to develop these methodologies for astronauts to have trust for a robotic vehicle to be operating that could put a hole in the space station at any moment if it suddenly didn't respond properly to commands and stop where it's supposed to stop, and to be controlling it with latency from the ground. And of course, that two-armed robot that's on the end, Dexter, has saved us countless spacewalks now. And so astronauts, love the challenge of a spacewalk, and so we're reluctant to give them up to Canadarm2, but we in reality, we gladly do as a program because it saves us crew time, allows us to do more science in space, but also reduces the risks that we have to place our astronauts in. So amazing things have been happening with Dexter and Canadarm2, and it just continues to evolve. And Nancy highlighted that well, but I really want to emphasize that. We are constantly doing more with robotics, and we're getting ready. We're learning with Canadarm2 right now some of the things we need to go into deep space with Canadarm3 on the Gateway, and these things are not trivial to solve. Of course, Canadarm2 is one of the ways that Canada brings real value to the international collaboration of the space station. And if you want to be part of this, that's the ticket. You have to bring something. We all bring what we have, our key areas in our country. We contribute them, we put them together, and we do one of the hardest things that humanity has ever done. We exist in space every single day. In fact, we just celebrated in the fall 20 years of continuous human presence aboard the International Space Station. This is a very significant achievement for humanity. For some of you on the call today, there's been a human in space aboard the space station every single day of your lives, and that's an absolutely incredible thing. But also highlighting that this is an important example of what we can do when humanity sets big goals big enough not to just inspire people within one country, but to inspire people around the world to come together to solve them. And I think this is an important example for our future, because as we tackle big problems, we'll talk about some of them today, climate change, for example, we need to do these things as an international collaboration. And sometimes we're reluctant to work with certain partner nations, or we have a history with them and we're like, do we really want to partner with them? Well, on the International Space Station, we're showing that it's worth the extra effort to do that. Of course, that's in low Earth orbit, and we're getting ready to go back to the moon with our eyes ultimately on Mars. Mike talked to us about the Gateway. This is a really important step for Canada to have committed to this for a couple of reasons. One, we want to be part of this international collaboration that will go back to the moon. It is part of our future economy. Being part of that lunar economy is going to be important for Canada. Also, it was a necessity and imperative that we joined on the Gateway project because of the Canadarm3 technology. This was an opportunity for Canada to push that technology to evolve it another leap, another order of magnitude, to be able to operate robotics in deep space with really high latency compared to what we have in low Earth orbit. And that technology, ultimately, the purpose, I guess the parallel purpose of it is not only to support Gateway, but to take that technology and leverage it in low Earth orbit, potentially on future space stations in low Earth orbit, on satellite servicing. That's really, really important for Canada's future. We have decades of experience in space robotics. It's really important that we carve out our niche of that future global space economy with a portion of the space robotics. And we have such a lead and advantage in that area. Of course, we need to take advantage of it. Ultimately, we're returning humans to the. Being part of Gateway means Canada is part of the Artemis Program. So for our contribution to Gateway, we have 2 flights for Canadian astronauts. And the first one will be Artemis 2, which will be a flight, it's supposed to happen in 2023. It'll be similar to the Apollo 8 profile, where take the Orion capsule out, leave low Earth orbit, test out all the systems, fly around the moon, and come back after a 10-day trip on a highly elliptical orbit back to Earth, just to wring out all the systems that we need to test on that Artemis capsule or the Orion capsule to get ready to return humans to the surface of the moon. Canada's contributions will not get a Canadian on the surface of the moon. They'll just get a Canadian into deep space. We are participating in some of the robotics operations on the lunar surface. And future contributions we might make is how we would see a Canadian walk on the moon someday. Something that's important to understand about Gateway is the mindset of the international collaboration around what we're trying to do here. We are not just trying to get to the moon and back. We are trying to set up a reusable transportation infrastructure that opens opportunities for the world to do new things on the moon, around the moon, looking out into deeper space, doing research on the far side of the moon, basically in the shadow of the moon from all the electromagnetic spectrum signal noise coming from Earth, and as a gateway down to the surface for humans, but also a gateway out into the solar system and onto Mars. And so the idea here is to welcome commercialization of this infrastructure and to make decisions that allow for companies to do what MDA is doing, where they build an arm for gateway, yes, but they do it in a way that they can leverage that technology to commercialize it for low Earth orbit, for example. And that's an important mindset shift in our exploration program. Now, of course, Mike pointed out, there's, what I'm talking about is space to space, truly exploration type hardware and initiatives. But we're very focused at the Canadian Space Agency in Canada at looking back at our planet, solving problems on planet Earth from space. And this is a huge area of opportunity for Canada. Also another area we have a lot of expertise and experience with. Many companies in Canada really good at providing some of these solutions, and the need has never been greater. You're now living in a world where in the coming years you will have internet on every square meter of this planet. That's incredible. As like not just internet, but high speed, low latency internet on every square meter of this planet. That's incredible. That's really important for equality around our planet, making sure that everybody has the opportunity to learn and contribute. This is an important endeavor. Climate change is a global problem, obviously, to anyone who's looked at it. Therefore, we need to solve it with global solutions. Well, space is the best place for global solutions. You put a satellite in orbit from north to south, and the Earth rotates underneath it, and you can image the entire planet from space with the same satellite over a period of time. So solving these issues on the planet becomes a really important priority for Canada. And so thinking about what can we do today on the planet that we can learn to take and then contribute what we've learned to allow it with our international partners to go into deep space. So that was a bit garbled, but what I meant by that was, I'll give you an example. So like food, for example, we have food security issues in the Arctic. So can we learn to grow food on the planet? Can we use the inspiration of space to grow food on the planet as if we're growing it on the moon or Mars, and learn how to get really good at it here on Earth first, and then take that experience to space? That's one example. Another example is medical. Can we solve some of the issues we have with delivering medical services in remote regions of Canada? Can we solve them here? Can we get really good at them here on the planet so that we can take that and barter it with our international partners and take it to deep space? And we know we can. And so these are just some examples. Energy, nuclear power, small modular reactors. This is another area that makes a lot of sense. Can we take that technology, leverage it here on the planet first, and then take it into deep space? Using those satellite networks to look back at our planet is super important for tackling a number of problems. Monitoring our coastlines, understanding ice and how it's changing, the Northwest Passage. The climate change aspects, you're probably noticing just watching the weather that it's changing. We have too much water in some places and then not enough water in other places, and then we end up with fires. For people that live in traditional manners in some of the isolated regions of Canada, they depend on animals and the nature there and fishing, and all of that is changing, and we can make contributions in collaboration, sharing this knowledge to help understand how to adjust and adapt to some of these issues. And I talked about growing food in the north, but we're already, of course, using space to help us feed the masses with more efficient and effective farming. Mike mentioned earlier about monitoring for illegal fishing. All these things we can do. These are important problems, and not just in Canada, they are global problems, and we can create global solutions. And when we create a global solution, we can export it, which means we can sell more of it. We can have more jobs for that expertise in Canada, and we get this exponential effect that's really important to understand. I just wanted to share this picture because it's a very visual way in which space has changed just in the last decade. We now live in a world where rockets blast off, do their mission, save enough fuel to turn around, land, and be refueled and reused again. That's incredible. When I first joined the space program, I listened to a lot of really experienced people, and they were very intelligent people. They had tons of experience, but they said this couldn't be done. Well, of course it is being done. And that's the kind of bold thinking we need. Mike pointed out today that MDA doesn't compete in the launcher space. Well, in fact, Canada doesn't really compete in this space either. In general, we have a new endeavor to have a launch site on the east coast of Canada, but we don't produce launchers, at least on this scale. And so what I want to point out to you is the reduction in the cost of getting things to space is all upside for Canadian industry. As things get cheaper to send to space, Canada can leverage this opportunity to do more and more at what we're good at where our areas of expertise lie, and make bigger contributions in space. So this is good news for Canada. So I just wanted to circle back to where I started, and that is, we do believe this global space economy is going to triple over the next 10 to 20 years. We do believe we have great companies in this country. We have a great agency, a space agency that's dedicated, great people at the agency who just want to see Canada thrive in that space realm. But we have to be hungry. It's not just going to fall in our lap. We intentional about how we take advantage of the opportunities, strategic about which ones we prioritize, to make sure we bring the maximum benefit back to Canada. And that's where you come into the picture. I just don't want you to think that you don't have an important role to play. You have a huge role to play. We can't do any of this without you. I have a tremendous respect for Mike Greenlee and all the opportunities I've had to interact with him, but he's obviously leading a group of incredible people. That's what makes these incredible accomplishments possible. It's not one person, it's a huge team of people. It's just like the astronauts doing that spacewalk I was talking about at the beginning. Astronauts are maybe the most visible element of human space exploration, but it is the enormous team on the ground that actually makes those things happen. And that's what we need to invest in, that team. We just want you to know that we need you to be a part of it and help us solve problems on our planet for the future. We got a lot of work left here to do on our planet for our people, solving equality issues. I believe space has an important role to play even in reconciliation. Obviously has an important role to play in climate change. And then obviously as we go on to the moon and Mars, there's just going to be some significant opportunities there for you and for Canada in general. Thanks for taking the time today. I'm super thrilled that you're interested in helping us take Canada into an amazing and incredible future of solving problems.
And thanks for the opportunity to talk with everybody today. I'm a big proponent of MDA from both before I came to MDA and then certainly since I've been part of the team here. So I'm really glad that all of you have had an interest in showing up today. You probably already heard from Mike Greenlee and others today about robotics and space operations, but I wanted to go a little bit more in detail. We have done some amazing work here, and we have an incredibly bright future in expanding space market. Start out with my slides here. If I can get them to advance. There we go. The things you probably already know, but just a review of some of the things that we've done at MDA. The Canadarm was on each one of the space shuttles, and it was used for scientific and technology experiments, flying around spacewalkers, deploying satellites, and then conducting space shuttle inspections. And this development led to the systems we have on board Space Station right now, the International Space Station, Canadarm2, the mobile base system that moves around with the arm, and the special purpose dexterous manipulator. All of these in combination were used to essentially assemble the International Space Station. Between the spacewalkers and MDA's robotic systems, we built this amazing platform in space. And we also continue to support Space Station for logistics and sustaining engineering for all the robotic systems every day with about 100 engineers that are part of our team. So super exciting work and really building our expertise over decades of our time in space. Now we're designing and building the Canadarm3, which will support the external logistics, the maintenance, the experiments, the spacewalks on the next space station called Lunar Gateway, which I'll talk about in a little bit. And we're also developing the next generation robotic servicing system for a growing commercial market. So as Kasha mentioned, I started with the company just a year ago because I was really excited about the work that MDA was doing and the direction that we're going. But I also had spent a good part of my career at NASA with hands-on experience with MDA's hardware. My first job in space, actually, I launched on STS-127 on Space Shuttle Endeavour. And then after, on flight day 4, we did a spacewalk. So first time in space, getting used to zero gravity, went outside and with Dave Wolf for our mission. And my job was to crawl over to the payload bay of Space Shuttle Endeavour, remove some covers, some sort of just manual work, but to get all the different payloads that were in the payload bay ready for deployment with robotic arms. And it just turned out that the way we had choreographed this, I was stuck in the back corner of the payload bay as all these arm operations are going on. So watching Canadarm on the space shuttle grab onto a payload, lift it up, and then move it to a position where Canadarm2 would grab a hold of it and then install it onto space station. Amazing opportunity and a lot to see on your 4th day in space. So I had another interaction with MDA hardware that I wasn't even familiar with until I came to MDA. So I was on board space station for a couple of months, and I was waiting for my ride home on STS-128 on Space Shuttle Discovery. So I didn't realize at the time, but it was the first test of the TRIDAR that was designed by a company called Neptech, which is now part of MDA. And this was a system, it's a vision system for autonomous rendezvous and docking in space. Doesn't require any markers, and it worked great. And it's been used on other space shuttle missions and then on the visiting vehicles that have gone to space station for resupply. So this is a view from STS-128 as it was coming in. That TRIDAR is scanning and finding the location, then coming into a position where the commander of the space shuttle could fly that in to the docking target, and then Discovery docked onto space station. And then I had a second opportunity to fly in space in 2015 and 2016 as part of Expedition 46 and 47. And while I was commander of Expedition 47, we had a visiting vehicle called Cygnus. We call it a visiting vehicle, but it's really just it's a cargo ship. And it would come out and it would hover in place using the TRIDAR that we built. And then once it's hovered in place, we'd use the symbology and the data you see in the upper left-hand corner. And then you can also see Tim Peake and I in the cupola, which is like this glass bottom boat on space station, working really hard to fly that arm in using the robotic workstation from MDA, and then getting to a position where you pull a trigger, it latches on to the payload, and then the arm is by the ground actually is flown into a position. We attach bolts, we repressurize the vestibule, open the hatch, and we can take out our cargo. But the Canadarm2 and all of the systems on board are an integral part of what we need in space. And really thankful I had this opportunity to work with MDA hardware and then be in a position now to help with this next generation of work. So now that I'm on the company side, I'm really even more impressed by the design, engineering, the construction, and now the support of space station. And all the other work that has led us to being experts in robotics and space operations. Over the years, we've developed capabilities for on-orbit servicing, the inspection capabilities for the space shuttle after the Columbia Space Shuttle accident, inspected all of the space shuttles, which was a very important task, working with Mars Rover capabilities, and then payload delivery systems in space. And now, we're on the next journey for MDA with the Canadarm3 program. So the Canadarm3, as you probably have already learned today, is a whole system that supports the Lunar Gateway, which is a space station that orbits around the moon. Unlike the International Space Station that orbits above our planet at around 400 kilometers, the Gateway is 400,000 kilometers away and will only be occupied a portion of the time. And so what that means is that we have to design and build a system that is largely autonomous, can maintain itself, and provide all of the interfaces for the arm to move to different locations on Gateway, and also install payloads and experiments. So the system consists of a large arm that does a lot of the work, and then you have a small arm, and the small arm is designed to maintain the big arm. And then there's a ground control system, an operations control center that will be located at our new facility in Brampton. We'll have all this ready to fly by around the end of 2026. Now, we also have a new challenge with Canadarm3 in that we're not only going to design and build the system, but we're also going to be in charge of operating and controlling it as well. So it's a huge opportunity and a lot of great work for engineers as we go through this process. So we're looking for the best and brightest of all the engineering disciplines that can help us with this really purposeful and important task. And really, I think one of the most important parts of Lunar Gateway, because it's going to be responsible for doing the end-to-end logistics on this way station so far away, and really enabling the next step, which is going to the lunar surface. So along with this Canadarm3 development and the previous work that we've done in the past, we're going to be looking at space robotics from a commercial standpoint. So Mike Greenlee this morning, or this afternoon earlier, had talked a little bit about this burgeoning market that will be used for things like active debris removal from low Earth orbit. There's commercial space stations that are on the horizon that you probably have read about, and certainly need robotics to support them. In-space assembly, the life extension for satellites, platform logistics and maintenance, and spacecraft augmentation. So it's a really interesting time in the space industry because we essentially have a new space race on all fronts. The Artemis Program, which I'll talk about a little bit in a moment, but on the commercial side as well, because we have this reduction in the cost of access to space. We have the technology that's really reached a certain place in time. There's much more interest in this, and we're really positioned from a technology standpoint to move in this market. So not just Canadarm3, but the future when it comes to what we're going to do in the commercial market. So a couple of things I wanted to talk about that may excite the engineers that have joined us today that I personally am really psyched about, because I think it's going to really facilitate the development for Canadarm3 and our commercial robotic systems. And that is the use of augmented and mixed reality that we've really been on the forefront of at MDA. And so we've used this to simulate a zero gravity environment, and also to understand the interactions between two bodies that are in zero gravity. And then what we've also done is coupled that with augmented reality. So you can imagine a design that you can overlay on our robotic systems, and then in turn really understand some of the dynamics from these two bodies in space, but then also the implications from an engineering standpoint. So it's a really amazing tool set that we're going to be expanding over time, and certainly using in our design and build for Canadarm3. And then along with that, how do we use these kinds of systems and that we'll design over the next few years for mission operations? Mission operations today are a bunch of monitors, people looking at data, but how useful would it be to have a really immersive environment, and how that contribute to really having better situational awareness, and then being much more effective in our operations that we'll have responsibility for. And also, this is maybe old hat to some of the engineers, but we're very excited about the use of rapid prototyping in our design and build process to really be able to retire technical risk, reduce the program schedule, increase the overall confidence that we have in the design. And so we have a strong capability already that we'll be expanding upon and using in the Canadarm3 program. So we've also been working on lunar rover technology for several years, sponsored by the Canadian Space Agency. And for us, this gives us the ability to understand and also compete with programs in the future for human exploration, for in situ resource utilization, which I'll tell you about in a moment, and also science. So this in situ resource utilization is a big deal because when we go back to the lunar surface, we need to have a sustained presence. That's the plan this next time around, as opposed to touching base and returning home. And so part of that is going to have this system that allows us to do that. And we're well on our way with the technology development that allows us to compete in a lot of the lunar programs that are upcoming. And this is super important when it comes to the Artemis program. So many of you already know about the Artemis program. It's an international human spaceflight program that brings together an international team. And the plan is to return astronauts to the moon, but this time to stay. And so we'll be establishing a sustainable presence on the moon. And it requires a whole system in order to make this work. You need mobility, you need the in situ resource utilization, whether it's water or growing food, life support, and then the ability to have autonomous operations. And so the stepping stone for us is the work that we've done in the past, the Candarm-3 development, especially the autonomy that we're building with an AI-enabled system, and then the rovers that will be used for both moving around equipment and also taking crew from place to place for the different science experiments that they do on the lunar surface. So the future on the moon is, I think, is really incredible. I wish that I had been born about 20 years earlier, because what you're going to see, especially once we get past the construction of Lunar Gateway, is this expanding market and capability on the lunar surface. And then when you look at coupling that with a lot of the commercial activities that MDA is going to do, it's going to be an extremely exciting time for human exploration. I really hope that you have an opportunity to consider coming to MDA. We would love to have the best and the brightest to join our great team. We have lots of really excited and collaborative people on our team in robotics and space operations. And that's exactly the kind of person that we're looking for to help us with these really big technical challenges. And I would say that they're not just technical challenges, but for me, these are things that have so much importance for our economy, for the human race, even when it comes to how we expand in the universe. And I think that MDA is absolutely the leader in this respect. And so I have a desire to be part of a great space program and a leading company. We want to hear from you, and we would love to have you join the team. So thanks for your attention, and Kasha, I'm going to hand it back over to you.
Great. Well, thank you, Tim, for this great presentation and for sharing your amazing stories with us. And thank you to everybody that has attended this MDA Virtual Career Fair today. I hope you all had a great time. As Tim mentioned, we're constantly looking for others to join Team MDA to ignite new and innovative approaches to problem solving that push us forward to improve life on Earth and above. Feel free to visit our MDA career site for any open opportunities and apply directly. And if you are as interested and as excited as we are, we'll take you there.